Hello, my name is AnkurMondal. Today I am discussing my results and observations in Digital Electronic Circuits Lab Experiment 1. So, the first objective was to verify the operation of 7-segment display in common anode mode. So, this is the circuit I made. As you can see, I have only put those pins in active low which I want those segments to be turned on. So, I have put an example of 3 such circuits, and thus I am going to run this circuit. So as you can see, the different digits are being shown according to the segments that I have put in active low. Only those segments will turn on that are put in active low, that is I have put them in ground. So this is verified. In part B, we had to use a PCD 7-segment display converter to display digits from 0 to 9. So I have not put all the digits, but I have shown 3 digits, 0, 1 and 2. So in 0, you know the BCD input will be 0, 0, 0, 0. So they are put in active low. In 1, we know it is 0, 0, 0, 1. So you see 0, 0, 0 and A0 is kept floating. Similarly for 2, A1 is kept floating because 0, 0, 1, 0. So I will run this circuit. As you can see, all the 3 circuits are showing proper results, hence my connections are correct. In part C, we had to verify the effects of BI, RBO, lamp test and RBI. So I have made 5 circuits side by side. In the first circuit, as you can see, it is a normal circuit. I have displayed a 0. On the second circuit, you can see that I have put lamp test on active low. As it is active low, so you can see all the segments are lighted on. So lamp test is verified. Now I put the RBI in active low. As you can see, it is on grounded. But you see that I am not showing 0 here. I have not put A1 as active low. So that is why it is showing a proper pattern. Let me run it. As you can see, it is showing a proper pattern because I have not tried to display 0 here. Simultaneously, on the fourth one, as you can see, I have put RBI as active low. Hence, whatever connections you do in A0, A1, A2, A3, it will always show a blank. Nothing, no segment will be activated. Similarly, in RBO, here you can see I have tried to display 0 here by connecting A0, A1, A2, A3 to ground, that is active low. As I tried to display 0 here, and RBO was grounded, hence that is active low. Hence you can see it is not showing the display. And whatever connections we do, and it will always show blank. So let's see. See, I have changed the connections. I have put A1, A2 as open. That is, they are not in active low. Still, there is a blank showing in the fifth circuit. But in the third one, you see, I have put A1 as open. That is, it is not in active low, so it is showing a pattern. Now let's suppose I connect this A1 to active low as well. Now let's run it. As you can see, as I tried to display 0 here, as RBI was grounded, so it will show no display. This same concept we will use to hide the trailing zeros. Like when we are trying to display 5, it would show 005 in normal case, but we will do such a connection that it will only show 5, as we will see in the next part. So the next part was to display a 3-digit decimal number with and without using RBI RBO. So here in the first one, I have used RBI RBO to hide the trailing zeros. In the second circuit, I have not used them. As you can see, Here there are no connections, so I will run this whole simulation. So as you can see in the first circuit, I have connected the RBO of the first converter to the RBI of the second, simultaneously RBO of the second to the RBI of the third. These connections helps us to hide the trailing zeros which are generally not used or not required. But in the second circuit, you can see I have just used normal BCDs and I have not connected RBI RBO, and there is no such complications in it, so the zeros are not hidden here. So why this happens, as we discussed in the previous part, that in RBI, whenever it is grounded and we try to show, that is RBI is grounded means it is in active low, and whenever we try to show 0 it will show blank. So RBI is in active low and we are trying to show 0 because A0, A1, A2, A3 all are grounded, that is active low. But see, there is no 0 showing in the second BCD segment, also there is no 0 showing, but here as it is 1 because we are not trying to show 0 here. A0 is kept open, that is it is not in active low, so it will show the 1 here. But the second circuit is simple because we are not doing such complications. The fifth part was to build a circuit to display all 16 patterns for BCD input 0000 to 1111 sequentially. So this is the circuit that I made. As you can see, we have used two extra components here, a pulsar and a mod 16 clock that consists of two up counters, a mod 2 and a mod 8 up counter. So let me run the circuit. So as you see, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and after that all the different patterns. But let me stop it. And as you could see that all 16 patterns were being shown. But now let's focus more carefully. 0, 1. In between 1 and 2, you see there was a different digit. Similarly, in between 4 and 5, there was a different digit. As you can see, there was some errors or some different displays that were being shown in between the 16 displays. That was a bit absurd because we didn't want them to be shown, but we can already see that our circuit is totally fine. So this was the problem I faced. I don't know what error I have done in the circuit or if some theoretical knowledge is missing, but I hope to know what extra components should I add to not show these absurd patterns in between, which are being shown in between the digits. Thank you.